Hello, my name is Martin Flint and I work for Egenera. This is the first in a series of online presentations to demonstrate Egenera's PAN Manager and to try and show you the flexibility and agility it can bring to your IT organisation. In this demonstration, we'll quickly cover the basic concepts of PAN Manager and then show you how easy it is to create servers using blades to run Linux, be it Red Hat or Novell SUSE, Microsoft Windows, or even using virtualization technologies on the blades such as PAN Manager's integrated VM Builder, VMware ESX, or Citrix Zen Server. Simply put, all of the manual effort taken to configure a physical infrastructure is virtualized, making it simple to manage your server environment using PAN Manager. PAN stands for Processing Area Network. The PAN architecture allows a PAN administrator to allocate hardware resources to one or more logical processing area networks, known as LPANs. LPANs in turn allow administrators to allocate the necessary resources to create servers and host applications. LPAN resources include processing blades, networking resources, and storage resources such as disk, tape, DVD, or virtual DVD. The configuration of your PAN and LPANs is stored in an XML database. This XML configuration can be easily transported from one PAN system to another, making disaster recovery very easy. For example, you could have one PAN system used for your production services and a second PAN system at a disaster recovery location, running your development and UAT services, perhaps using virtualization such as VMware or VM Builder. In the event of needing to invoke disaster recovery, it would simply be a case of repurposing the blades used for UAT and development by importing the XML configuration and booting up the production servers. We have many customers using this facility today, providing their businesses with better agility and flexibility, along with a substantial cost saving to their IT infrastructure. PAN Manager is able to do this by using a converged I/O infrastructure. This is at the core of our product, and PAN Manager has been using a converged I/O infrastructure for 10 years. As you can see in the diagram below, physical servers typically have many network interface cards and host bus adapters. On production systems, the number of cards are typically doubled to provide high levels of availability for multipathing. Each server has a console connection or KVM connection. All of these additional components drive up the complexity in your infrastructure and reduces your flexibility. Using a converged infrastructure, PAN Manager allows servers to connect to your network and SAN, and at the same time reduce the number of physical connections in your infrastructure by reducing the number of host bus adapters and network cards needed, thereby reducing the amount of switch ports required on your SAN and networking infrastructure, and simplifying the physical cabling. More importantly, we do all this using standard SAN and network switches that you have in your infrastructure today. You won't need to buy new converged network adapters or any specialist multi-protocol switches. This converged fabric is the key to allowing PAN Manager to perform functions such as N+1 failover, disaster recovery, and the ability to rapidly repurpose servers and help reduce your infrastructure costs. In this screenshot of the PAN Manager GUI, you see what a typical server configuration looks like. Here we define the blade to use. This is either a physical blade or virtual blade. We could assign a pool of blades that are available for use. In this case it's a 4-socket 12 GB processing blade. You could, however, use PAN's VM Builder and just use a portion of that blade, for example 2 virtual CPUs and 4 GB of RAM. The rest of the blade could be carved up into smaller chunks and used to run other servers in the LPAN. Another important benefit of PAN Manager and the use of its converged fabric is that the blades are stateless. By this I mean they have no real identity. So for example, if I wanted to upgrade the server running on a blade controlled by PAN Manager, it's very easy. We just slot in a new blade and assign it as the primary blade in the server's definition and reboot. Then we can repurpose the old blade for some other task. Now think about how you would do that on more traditional physical hardware, which have a state such as internal disks, MAC addresses for the physical network cards, worldwide names for the host bus adapters, or even host IDs. The time taken to upgrade to a newer generation of blade can literally be done with a couple of mouse clicks, and the time it takes for the server to reboot, which is typically less than 5 minutes. On a physical system, you could be looking at several hours with days of planning. Here we provide details about the virtual network interface, such as which virtual network switch it connects to. In this example, we have one network interface connected to a virtual switch, which is uplinked to the outside world. If this server needed to talk to another server in the PAN system, we simply need to ensure the other server has a virtual network interface connected to the same virtual switch. Then these servers will communicate across the converged infrastructure. Here we assign disks from your SAN to the server. We can also assign a SAN disk to multiple servers should you need to do clustering, such as Oracle RAC or Microsoft Cluster Server, or set up a pool of ESX servers using shared storage to provide vMotion type services. Here we define the type of operating system to use. We support Windows 2003, 2008, Linux, be it Red Hat or SUSE, Citrix Xen Server, VMware ESX. Finally, here we define the failover policy. We can assign a dedicated failover blade or a pool of blades to failover onto if the server has a hardware failure. Many of our customers have decided that they no longer need to have clustered HA solutions and simply use this, since the downtime is usually time needed to boot the server and restart the application. This can help reduce software licensing costs, hardware costs, and reduce the complexity of building HA clusters using traditional physical hardware. Other customers have chosen to use this to complement their HA clustering, to keep services running as resilient as highly available as possible, to maximize their uptimes. In this slide we attempt to show you how servers in PAN Manager would connect onto the network. As you can see, we have three LPANs: marketing, sales and service. The marketing and sales servers are connected to a virtual switch 1. They can communicate to each other over the converged fabric. The servers in the service LPAN are connected to virtual switch 2. They cannot talk directly to the marketing or sales servers. Network traffic would need to leave the PAN system via the Ethernet interfaces on control nodes named C-Blade 1 and C-Blade 2 in this diagram, and go out via the external network infrastructure. You may want to do this if you need to use a firewall, or just need to completely separate secure networks if for example you're a service provider. This slide tries to illustrate the storage connectivity side of things. This diagram illustrates a fibre channel SAN environment, but some PAN systems do support iSCSI connectivity if that is required. As we can see, we have three servers. Each server has multiple paths across PAN's converged fabric to each control node, named Control Blade A and Control Blade B in this diagram. The control nodes have multiple fibre channel HBAs that can connect onto your SAN. This allows the PAN systems to multipath across the converged fabric and then perform multipathing onto the control nodes out onto your SAN storage. Your SAN administrators simply perform the zoning and LUN masking to the two control nodes, which appear as a two-node cluster on your SAN. Then, once the PAN system sees the LUNs, it's simply a case of assigning the desired LUNs to the correct server definitions. This vastly reduces the administration complexity involved in adding storage to multiple servers, such as 4 or 8 node clusters. PAN can also support fibre channels to tape if required. Now you have had an introduction to Egenera PAN Manager, let's go through a couple of demonstrations. First, we'll build out a server using the GUI. Second, we'll build out a server using the command line interface, so you can just see how easy it is and how easy it will be to automate this process. Then we'll move on to showing you how you could build a virtual server using PAN Manager's VM Builder, and how this is fully integrated into the PAN Manager application, so your IT staff don't need to be experts in multiple virtualization technologies and can use one unified management interface and focus on delivering your business's requirements. Finally, we'll show you just how easy it is to set up N+1 failover using virtual or physical blades.